And as this was a new course, of course, we had some motivations to do it, to develop it. How did we want to run it? At first, the first thing was that it was actually asked. We did this course on a topic that interests us, of course, but we were asked from the department, or rather the section, to develop this course. Then we found it very motivating because we find the topic so interesting. So, of course, the technical syllabus was very interesting for us to develop, and that was also a motivation why we developed this course. And now I should tell you that this is an elective course. It's for master students, but it can also, bachelor students can also come to the class if they do. And since we have it as an elective course, we believe that the students we have, they take this course because they find the topic interesting, and also because they can see that they can probably visualize that they can probably use the things that we teach them in their future career. Therefore, we decided when we should our teaching methods that we would enable the students to visualize themselves as civil engineers after this course or during this course. This should keep them motivated during the course, that they could see this. So that was when we chose that is the overall learning vision that we chose, and from that one we have chosen the teaching methods. And of course, not of course, but we are a bit selfish also, because we also would to use this course as recruitment of very nice, good and engaged students for our research projects. So they can, well, we get in contact to them and we can have them with us later on. So that's also a motivation to do a good course, of course. Then very briefly about the course. It is called Materials Durability and Repair, and it's a 5 ECTS course. It's taught once a week in 13 weeks, 4 hours each time. And we have actually a limitation of the students. We can only take 25 students. That's from practical reasons, because we use a lot of lab equipment, and we can only take 25 persons. We have run this course 3 times. This presentation is only about the first 2 times, because the 3rd time has just finished. We did not include this in this presentation, but as you can see, we have a waiting list, so there is a demand for such a course. Then the course objective, as we tell it to the students, is like this, that the participants will be able to determine damage mechanisms on construction materials in various situations and act upon the findings by suggesting an appropriate repair method. So that's the overall learning vision of this course. We decided to include 3 groups of materials, you could say. Concrete, one of them, stone and brick, the other one, and wood is the third one. So we developed this course on basis on these different materials. And the students know from the very beginning that they are going to do a final assignment, which is a small project, going to choose which of these materials they're going to work with. They know that from the very beginning, so they can start to feel what could I be more interested in than the other from the very beginning. And we tried to reach active learning through a combination of excursions, lectures, and experimental work in the course. And Iben will tell us about it.
Yes. So this, I will talk to you about these 3 main teaching methods that we used: excursions, lectures and exercises, and laboratory work. And excursions this is pictures from an excursion of a concrete bridge, where the students meet with a guy from an engineering consulting company. He tells them about this bridge. He tells them about what could be the problems here. He guides them into how to take the samples and what to look for. And the students actually take their own samples and bring them home in the lab. I think this is a very nice picture of this. How does this work? Yes, that's how it works. Yes, he was able to drill holes there. Another excursion, and that's for wood. We have actually 2 excursions. This is the most popular excursion that we have on the course. We go to Bang, this amusement park just very close to here, where they have the oldest wooden roller coasters in the world. And we have the manager of this roller coaster, he will guide them and talk to them about specifically on the durability and repair part of this. How do they actually inspect the wood? How do they change the wood? How do they make decisions when they change it? And then he lets them walk on this roller coaster. The teacher, me, is not on the top there, but the students, and I think actually Lisbeth was there as well. Some of us stays a little below, but they like this excursion very much. And actually, he also gives them a tour of the roller coaster after that. So, but this excursion, we use these excursions as a method to get like real-world scenario into this course. This is a way for them to see how does engineers work, meet with them in different situations, their own work situations. It also gives the students a common knowledge platform to take home when we go back into our classroom. They have seen what does wood decay look like, what is the problems here. They have seen salt-infested brickwork in Copenhagen, and they know what the problems are, and they have seen it. So they have a common knowledge platform when we start the discussion or the work in the classroom. So having the excursions first before we go to the classroom gives us, our experience is that we have very curious students, they come to the classroom because they say, why is this? How could that happen? Or why would that look like this? So they have seen something and they wonder, and that's always a very good start, I think. And also, they take real samples. Don't give them samples and say, like samples that we have spiked ourselves so that we know we'll have a very good chloride profile into this concrete. They actually take these samples themselves, and then they have to look at the results. So they don't always get maybe the results that we expect or that the theory said should be this profile. They could get another profile, and then there's something to discuss again. The lectures and exercises is, we go back into the classroom. We have, they often, when it's possible, of course, there is some logistics sometimes makes it impossible to do this, but most of the times we have succeeded in this, that the lectures would follow the excursions. There's a theoretical approach here. This is where we teach them the theory behind, and we do that by PowerPoint presentation, the blackboards, and we also do evaluation excursions. We talk about excursions. What did we see? What do we expect? What do you have of questions? Because sometimes you will also have students that they have the best questions where they're standing there, but they dare not ask the man because they think maybe it's a stupid question. So they will wait, and then they will ask us, which are clearly not the experts on the subjects, but we will try to answer them to the best of our ability. We do some exercises. We do exercises in the classroom often. If we have, they do papers as part of this, and when we do evaluation of the papers, then the rest of the groups will do group exercises that we will then go through at the end of the of the class. And also we try to make these exercises as relevant as possible to them. Like this could be exercises in measuring or calculating something that they will actually use in their final assignment, also later as engineers. So this is, we try to make it as relevant as we can. We put this into focus anyway. The third thing that we do for the teaching method is the laboratory work. They go into the laboratory, and here you see some of the shiny, happy, dedicated students doing some lab work. But we have different methods that we use here. The active learning is like you have the hands-on. They are doing the work. We give them maybe the instruction how to use this apparatus, but anything except for the SEM, they are allowed to use for themselves. The SEM we have an operator for. But they actually do both very simple methods, like dropping a solution onto this and see if it changed the color, and then we discuss what this change of color could mean, or why this change of color is there and not there in concrete. And they also do SEM analysis, the scanning microscope, where they do very sophisticated analysis of maybe the presence of different salts in salt-infested brickwork. And then the final project, they do papers through on each of the subject, or that we'll talk about the assessment later, but we have smaller assignments and have this what we call the final project, and they are introduced to this. They know right from the start they're going to do this final project, and it's going to be in one of these three topics, in these three materials we talked about, and then it's actually more or less you decide what you would like project on. We tell them that you are responsible for the design, for the process, for the outcome. You do the material, you find the case, include experimental work. It has to be kind of experimental work in there because this is defined as an experimental course. And they do the actual project, they write an article, and they present it at a poster. And we try to make sure that they do this. We emphasize that you have to find your own case, so you better get started. And of course, we have some cases that we can think of, or we can know where they can contact, so that they can get started in due time to be able to come up with the project at the end.
So let me briefly tell you where we use the companies that we're working with. The companies are people that we know from our network. We have done research projects with them, or we have been introduced to them by other means, not during the course actually, but we know them on beforehand. And what we used them for was not so much to set the syllabus of the class, or what do we want to teach. We decided that, but then we asked them to join us. And we have asked them to plan excursions for us. They have been teaching, as you saw, at the excursions. We have what we call a seminar. One of the classes is a true seminar like this one. The students there, people coming in from industry and giving presentations on relevant topics. And that can be topics from very practical. If one brings a bag and shows what she wears when what she brings when she wants to go on inspections on bridges. And another one is much more scientifically on cathodic protection, for example. So there's a wide range of different industry persons and presenting work here. Then we have industry helping us finding cases for the final projects. And then they also deliver material samples. For example, we have a piece of wood here that was delivered by one of the industry, and we also get samples to show in class from different companies. So these are the different places where we involve the companies. And actually everyone we have asked has been extremely positive to our inquiry. Nobody has said that they were not interested in participating in the course. They are not paid, know anything. They get a bottle of wine if they go to the repair seminar and give a presentation, but that is it. Everybody has been very positive. The only thing we have seen that could be a problem is this course is given in English, and some people do not like to give or present things in English if they are natively Danish speaking. So a few persons have excluded themselves from joining the course from this reason. We have had a few cases where we thought that the topic was so much in line with the course that we allowed them to give the presentation in Danish, but it doesn't really work because we have perhaps 4 or 5 students there sitting there not understanding what's happening. So we will not do that again. The assessment of the students here, we also try to use tools that they are going to use when they finish. We will not have student reports. We want real journal papers. We give them a template and everything, introduce them to how to write such a paper, and they give. The first time we ran the course, they gave us 4 papers, 4 articles, and they also made a poster. That was heavy workload to read these papers, and also the students to write them actually. So we decided for the next time that we only made 2 articles, and then we made some quizzes, also a poster. And the quizzes was a very good idea, and we continue on that because it makes it easier to do individual assessments. We really need to know every person is sitting there on his or her own during these quizzes. But that's, yes, 2 minutes. Okay, I'll run through it then. But we have posters and papers. This is just in brief. We did not do a survey from the students. This is not a survey from DTU, and I just wanted to show that students think that the teaching should encourage their active participation. You can see it from the orange color, and just create a good well, between the different teaching activities. And then throughout the course, we have communicated somewhat to them where they stand academically. You see that this one could be improved a bit, or at least one person that's satisfied. He was the one who was always running late, I think. Well, this one on the practical issue, it could be my last slide, and we run quickly through the conclusion. We decided this one. This was the core of our class, but involving all this industry means that we do not know all the details that will be taught. It's loosening up a bit. We do not know exactly which frame the course will be put in each time. The core is the same, but where we put it, it depends very much on, for example, where do we have interesting sites to show? What's in the neighborhood of the university? Where should we bring them? It could also be details in the company person, in the presentation of the company persons. It varies from time to time. It's not the same persons that we engage every time. So it can also vary a bit. And also, well, what does a sample show us? And also the analytical results, what do we get? Where to discuss the things so that we can understand the results, and it's not always the same. So it's involving all these industries, loosening up a bit. It's loosening the grip. And it takes, of course, it takes time when you design this course, when you engage with all these people, it takes time. But I think we win again when we have all these engaged students who are interested in the topic. And well, I think the conclusions I will not, as we are so late, I will not run through them because you just heard what we said. But finally, something should do. Yeah, these are the company who has been, or the person who has been involved that helped us out so far. And of course, I'd like very much to thank them because they really make it possible to make this course interesting for the students.
Thank you.